This program is an example of using the current random number generator in C++ that was implemented in C++11. So it's a little newer than the srand and rand functions that come with the C standard library. And this program also demonstrates how to use a vector, but use a vector that has a type of a programmer-defined class. So let's look down at main, and then we'll look at some of the class elements. And this program's on your Canvas page, so you can take a look at it. So here's main. Line 80 starts with just a seed of the random number generator. The new one, there's a way that you can seed it with a random device generator. But there seemed to be a little bit of system dependence, and I wasn't always getting good results with that on my system, so I went ahead and just seeded it with the time, just the same way that we would seed the srand. So then line 81 is this vector, and it's going back to class rock. So we're going to call it myRock. That's the name of the vector. So let's look back now at class rock and see what this is doing. The reason I wanted to go over this program with you was as you're working on your projects, a couple of you were going to do card games. And so kind of take this program as a example of how to set up a deck of cards. In this case, we're using it to set up a mineral set, and we're going to load all the minerals in and their masses, and then we're going to go back and randomize them. And at the same time, let's look at how to use this new random number generator. So to use the random number generator, this current one, it's a # include random. We still need seed time because I'm using the time to seed it. And then it has several different types of generators. So if you Google search on random and C++, it'll give you all the list of the different random generators. I'm using this one, MT19937. And then you can generate both integers or floating point or doubles. So I wanted to generate a double just to show you that you can do this. And so to do this, it's std::uniform _ real distribution. It's different for the integer. And then you use the type that you're using, so float or double. And then the name that you're going to call the distribution function, and then in parentheses you give it the limit. So we're going to generate numbers that go from 0.0 up to 100.0. So let's look at our class rock. So again, this is very similar to what you would do if you were using playing cards. So under the private data we have a string that'll be the type of the mineral. If you're doing playing cards, you could have a string that was the suit, so hearts, clubs, etc. Or you could do a character that would be the suit, so H for hearts, etc. And then you'd have a face value, so an integer value if you're doing a playing card. In this case, we're going to do the mass of the sample, so we'll do float mass. And then we need to do one more thing that's not real obvious, which is why I wanted to do this example with you. We have to include a random number in each of the rocks that we create, and then we're going to use that to randomize it later. So that's what this is, this random number storage space. And then we have the usual default constructor and a parameterized constructor. You'll need to also overload the less than operator so that the sort routine will work correctly when we sort it later in main. The syntax with this, we've talked about this one before. It's a little bit complicated though. You might want to just copy and paste this line 25 over into your program and then modify it as you go. But the idea is that whatever you're calling the right hand side is in parentheses right after the operator, and then the left hand side is doesn't get a name. You're just using whatever variables you have with your class, but it goes here after the parentheses. So we don't want to change them when we're comparing them, so we're going to do const to say it's a constant for the right hand side and also a constant for the left hand side. And then we have just the basic member functions to get the mineral name, get the mass, and then get the random number generator. So let's take a look at our constructors. So to run this new random number generator, we have it up here again as a global because we want all parts of our program to be able to use the random number generator. So we called it dist. So then when we use it, we do rand equals dist mt. And the mt here is the instance that we're setting up of this particular type of generator. So this says go and get it, use this generator to go and get it. So then this will create that number from 0 to 100 and store it in rand. And then for our default case, we'll set the mineral equal to quartz and the mass equal to 1. For our parameterized constructor, we'll get a string that will store in the name of the mineral. We'll get a mass that will store in the mass, and then the random number generator works the same. Now when you're dealing with your operators, you can go ahead and define a greater than operator if you want to, but really the only one that you absolutely have to have for sort to be able to work is the less than. So I went ahead and I commented this one out just to show you that it would run without it, that the only comparison in sort is actually that less than operator. So then this is the same statement that we had before, just missing the semicolon on the end because that one up there was a prototype. And then we have to scope this back to rock. So it's bool rock : operator, the operator that you're overloading, what you're calling the right hand side here in parentheses, and then whatever information you're providing for the left hand side. So it's the left hand side is going to be a constant, right hand side is going to be a constant. We're going to call it RHS. So then we have a Boolean variable that we're creating that's going to be a default of false. And then if ran, so that's the private data from the class. We're in the class so we can still access the private data, is less than, this is the left hand side that we're doing here, is less than RHS.ran. So we're using RHS because this is the instance now that we're using for the right hand side. So if that's true, then we set our flag equal to true, and then we just return flag. And then for greater than, it's exactly the same thing except it's a greater than in the if test. And then the get mineral just returns mineral, get mass just returns mass, and then get rand just returns rand. So let's look at how we can use this now with our vector. So again, line 81, declaring a vector instead of int or float or double or string, we just put rock inside. Rock was the name of our programmer defined class. And then I want to load up the 10 fairly common mineral types onto it. So I've got a string that's these different types of minerals. If you're doing playing cards, you would do a vector of a string, and then you'd have your suites here, so hearts, clubs, etc. And then I've got 10 different minerals, so my outer for loop is going to chug through all those different types of minerals. So 0 to 10. If you're doing playing cards, you'd want to just run this 0 to 4 because you'd only have 4 different suits in a standard set of playing cards. And then my internal one, I'm going to use that to scale it up and then use it for the masses here. So this internal one, if you're doing playing cards, you'd want this to be the face value of your playing card, and you might want to think about encoding it so that maybe the ace is a 1, and then once you get through 10, you still have the jack, king, queen, and so forth. You might want to do the jack as 11, the queen as 12, and so forth. Or instead, you could set up another vector that was a char vector, and you could use A for ace and then go 2, 3, 4. As long as you put single quotes around them, the numbers could still also be chars. But either way that you set this up, you'll use a statement that's very similar to this. So you'll do the instance that you created. This is your back to the name of your vector, so it'd be my rock. Since it's a vector, it already has the pushback function built in, so it'd be push underscore back, open parentheses. Now here's where it gets a little bit different when you're using a programmer defined class. So you'd go back to the name of your class. The name of the class is rock, and you're going to use your parameterized constructor in this case, because that's going to allow you to change your mineral and your mass. So that's the name of the class, open close parentheses, and then we're going to send it the mineral, and we're going to send it the mass, separated just by a comma. So it's almost like a call to the constructor that's being done here, and that's creating that new element of the rock and then putting it on this set of rocks that's our vector. Notice we're doing mineral sub I, so that'll go through and it'll start out when I is 0, it'll give you olivine in here. Then when it goes through and does I is equal to 1, it'll give you augite and so forth. And then in this one we're doing J times 10, so this will just scale up the integer values from 0 to 10. Just setting the formatting here, and then I've got a function to print the rock, to print that set of rocks that we've created. So I'm going to send it the vector name. And then here's the other thing that you'll want to look at. Now we've done this sort before, but just to see it's the same sort of setup that we've had it before. So std : sort, you've got to include algorithm up top for sort to work. And then it would be your first value and your last value. So myRock.begin, open close parentheses, comma, myRock.end, open close parentheses. Now it's going to sort based on that less than sign that you defined, and the less than sign is only going to look at the random number. And then we'll print it out again just to show that it's randomized. And then here's our function to print it out. So we've got just a prototype of the function before main so that main knows that it's coming. And then here's our function after main, so it's void, it's not returning anything, print underscore set. And then look at that, it's receiving that vector just like it's a float or a double or anything else, but it has this type rock in there, which was that programmer defined class. So here's our for loop, and our for loop's going to go through, and then look at how this is now being accessed. So this is, we're calling it V on the receiving end. So it's V, and then in the square brackets, the element that you want. So this is element I, and then close that square bracket, and then you can access then any of those public member functions. So get mineral, get mass, and then get rand down here. And the set W's are just to make it look a little bit cleaner when it runs. So let's run and see what it's doing. So let me scroll back up to the top. So here we go. Here's our mineral. I guess I probably should have added 1 or something to mass in gram. Doesn't really make sense to have a 0 mass there, but the processes would still be the same. So there's our mineral, there's our mass, and then there's the random number that was assigned. And then after we go and we sort it, now look, the random number's in ascending order, but since we assign that random number randomly to our vector, it completely sorted everything else in a random order. So now our albite with mass of 0 is up at the top, followed by the biotite with the mass of 70. So this would work exactly the same way with the deck of cards. You load all those suites on. That would be like your first portion here. Load all the face values on here. Calculate those random numbers for each card. And then you just sort the deck based on the random number. And then once you do that, then your deck's gonna be shuffled in random order. And you could even deal from 2 decks if you wanted to. And then to get rid of something off of here, there's a function called pop back. So you can read the value from a portion of your vector, and then you can do .pop underscore back, and that'll actually remove that last value. So when you're dealing your cards, read the card, do the pop back to get rid of it. You can read the next card, pop back to get rid of it, read the next end of card, and do a pop back to get rid of it. So for those of y'all thinking about doing card games, let me let you work on this, and then when you have questions, just let me know. Thanks for watching.